Hello and welcome to the 18th tutorial in the C++ programming series, and in this part we're going to look at bitwise operators. So bitwise operators, as the name suggests, so if you've done computer science or programming before, is where you're affecting the bits of our variables, values and so forth. Bits, aka ones and zeros, binary, and that is the lowest level in computers because everything eventually just goes down to ones and zeros. All of this is what you're using, computers and whatnot, even the microwave with the electronics is all built on top of ones and zeros. On top of that, there are several of the layers which we would generally interact with, but the need may arise to interact with the bits itself. So let's just go ahead and open up our project and show you the different bitwise operators. To truly get a grasp of binary and bitwise, you really need to look into like twos, complement, etc. and just general binary. A quick Google search and a general read for half an hour or an hour will give you a good overview of what it's all about. But this tutorial is to show you how to actually use it within C++. So let's get rid of this a second. And the first one we're going to look at is the AND operator, which uses the ampersand. Next one is the OR operator, which uses this vertical line. Don't know what the vertical line is called. The next one we're going to use the exclusive OR operator, which uses this upside down triangle, or some people call it a carrot, I think. And we're going to use the tilde, I believe it's called a tilde, which is the NOT operator. It's basically a unary complement, it's a bit inversion. And that is the tilde. Then we're going to use the shift, the bits to the left, it's to the left, the less than operator. Sort of what we use in C out and C in, but its actual usage in here in this instance will be different. Next one we'll be looking at shift bits to the right, and as you guessed it, it's to the right. So let's just do a C out. STD color column and line, and in here we are simply going to put 5 and 3. Put these in brackets. Now run this bad boy, and we get a result of 1. Generally on the outside, if you're not aware of binary, you might think of it, how would 5 and 3 equal 1? It might equal 8 somehow, because maybe you add them together. No, it doesn't. Let's just quickly show you what it's all about. Like I said, generally if you're doing this, I recommend you look up into computer science and learn a bit about binary, but here's just a quick overview. So we're just going to be using 4 binary digits for the purpose of this little simple example. So 0000 is 0. And the first digit, which starts on the right, represents the value 1, then the next one represents the value 2, next one represents the value 4, I think you can guess the next one represents the value 8, and so it's just 1, 2, 4, 8, 16, 32, 64, 128, so forth. And to build a number like 5, what you do is you look at it like this, and from the left you look, okay, the first one represents 8, does 8 go into the value 5? No, so you put 0. Does 4 go into the value 5? Yes, so you put the number 1 there. So you put 1 or 0 on or off, sort of like Boolean. So what is remaining is just 1. Does 2 go into 1? No, so it's a 0. Does 1 go into 1? Yes, it does, and now we've made our number 5 in binary. Let's do the same for 3. So does 8 go into 1? No, it does not. Does 4 go into 1? No, it does not. Does 2 go into 1? It does indeed. And what we have left is 1. Does 1 go into 1? It does indeed. So let's just sort of separate this. And what we're going to do is the result of this. So for the AND operator, it goes through all of these and compares each binary bit with each other. So what it does is, we can just do it from the left, 0 and 0. For AND, both of them need to be 1 for the result to be 1. So 0 and 0, it's 0. 1 and 0, only one of them's on, so it's 0. 0 and 1, only one of them on, which is 0. 1 and 1 is 1. So let's just go over this again. 8 times by 0 is 0. 4 times by 0 is 0. 2 times by 0 is 0. But oh, what's this? We got for the 1 section, 1 times 1 because this bit is on. So the result of this is 1. You can easily apply it if you have a larger number or a different number. That's the rough general gist of the AND operator. I will comment this as AND. Let's get rid of this. And now let's just show you the OR operator. Like I said, if you want more information, you can message us and we will help as much as possible, but a quick Google search should suffice as well. So let's just do the OR operator, comment this out for a moment, run it, and we got 7. So let's just show you how this worked. This is seeming like to be quite a long tutorial. Thought it'd be quite a short one, but it's one of those things, I guess. And let's just center this up. And for the OR operator, it looks through it and checks only one of them needs to be on at the bare minimum. So 0 and 0, none of them is on, so it's 0. 1 and 0, 1 is on. Okay, the top one, we'll put the other 1. 0 and 1, one of them is on, we'll put the other 1. 1 and 1, one of them is on, we'll put the other 1. So we got 0 there, we got 4 plus 2 plus 1, which equals 7. I hope you're sort of seeing a pattern, you're seeing how it works now. Let's do the exclusive OR. Let's just get rid of this a second. So let's get that upside down triangle caret thingy, run this. We got 6, and the exclusive OR basically says for the result to be on, only one of them can actually be on. So we'll just show you by using this example. So the first one, 0 and 0, nothing is on, so it's 0. 1 and 0 is on, so it's 1, because at least, only one of them can be on. 0 and 1 is 1, but 1 and 1 is 0, because it's exclusive, or only one of them can be on at any given time. So it's 0 plus 4 plus 2 plus 0, so it's 4 plus 2, which equals 6. So let's just copy and paste this. And now let's just check out the NOT operator. Where is the NOT again? There it is. The total should say. So this has done -6. This is something we're going to look into a little more. Basically, this is 2's complement. Let's make a little note in here so you can check it out. Not /dot. Not check out more info on 2's complement, and you will understand what this is going on about. But this just basically inverts the bits, so 1s become 0s and 0s become 1s, and obviously because using the sign bit at the end is a negative because we're using 2's complement. Again, a lot of that might just mean hoogity boogity to you. I could have just said that and you might have just understood the same amount, aka nothing or very little. So it's something that you're going to want to research, because I'm just showing you the features within C++ that allow you to do these operators. If you want some more information, it's best if you Google it or just message us. So let's just show you the last two quickly. The bitwise operator, the shift bits, put these in brackets. We're going to do 5, no 6. I'm going to shift that, and now you specify how many times you want to shift it to the left. And because this is pointing to the left, that's how you know you're shifting it to the left. So we are shifting the value 6. We're going to shift this bit 2 points to the left. So let's just run this. We got the value 24. Let's just show you how this got to the value of 24. Let's get rid of that. This is shift left bits. I'm going to put SBL, shift bits to left. Oh, SBTL, shift bits to left. And 6, I believe, is 0. 0, 1, 1, 0. I'm going to put an extra 0 at the end simply because that's what we're going to be dealing with. So what this does, and it goes through them, and you basically just shifts each bit 1 to the left. So this remains a 0 because this one goes there. The 1 goes to where this one is, so 1. Then that one goes to where the other one was, so 1. 0 goes to there, and anything that we can't see on the right, you can assume that as 0 as well. So let's just go over this, how this produces 24. So it's 1, 2, 4, 8. Just give me a moment for 2. Oh, sorry, my bad. Meant to be shifting it 2 places, not 1 place. Actually, no, we can leave that, and we can just say first shift, and then we can put second shift, as in is shifted it 2 places. So we have 1, 2, 4. And these last 2 are 8 and 16. 16 plus 8 is 24, hence why it's printed out 24. So let's just show you the final one, which is shifting it to the right. And we're just going to show you shifting it 1 place, and now let's run it. Should be like 3. So let's just copy and paste this. Shift bits to right. And we can just get rid of this. And get rid of this a second. Also get rid of this, and what it does is shifts all the bits to the right now instead by the specified amount, which we have put as 1. So we go 0, 0, 1, 1, and we know that is the value of 1, that is the value of 2, so 2 plus 1 equals 3. So hence why it prints out 3. That's it for this tutorial. This was quite a long tutorial compared to the other tutorials in this series. If you have any questions, feel free to message us at support@sonnarsystem.co.uk. The email will be in the description. You can comment on this video or just directly message us via YouTube, whatever you feel comfortable with. All the required links for source code will also be in the description. In the next tutorial, we'll be looking at the size of operator. And as usual, thank you for watching, and I hope you have a nice day.